Thank you all very much for coming. We really appreciate you sticking around and coming on the last day of the conference. So this is going to be a tutorial from going about how you use Kubeflow to go from a notebook to a pipeline to do end-to-end data science. I'm here just to give you a brief overview. Really appreciate everyone coming out to do this. So my name is Jeremy. I'm one of the tech leads for Kubeflow at Google. I will let my co-speakers introduce themselves. Stefano, Ilias, do you guys want to introduce yourself?
Sure. Can you hear me? Okay, so I'm Stefano. I am a software engineer at FBK, a research institution in Italy.
And I am Ilias Katsakioris. I work for Arrikto. I'm a software engineer, and that's pretty much it.
Great. So I'm just going to kick it off with a couple of quick minutes, providing a brief overview of Kubeflow. And then I'll hand it back to Stefano and Ilias to go into the technologies that we're going to be using today, and then go through the code lab. So what is Kubeflow? Kubeflow is an open source project that's dedicated to making it easy to deploy machine learning on Kubernetes, right? So our model is to make it simple, portable, and scalable. So this slide is meant to indicate why we started building Kubeflow. So what we saw about a couple years ago was that if you looked out in the world and you looked at what were the companies that were being successful with machine learning, all of the companies that were at the cutting edge of machine learning were really talking about the platforms they were building to do machine learning and how critical that was to be successful. So Google was one of the first. They talked about their internal and now external machine learning platform called TFX. But other companies like Lyft and Bloomberg were often talking about their platforms at KubeCon and other places because they were built on Kubernetes. And so what we saw with a lot of these platforms, particularly from like Lyft and Bloomberg, is that they were building on top of Kubernetes. They were also building on top of open source applications like XGBoost, Jupyter, frameworks like PyTorch and TensorFlow. And what they were really trying to do with these ML platforms was make it really easy for their data scientists and ML engineers to be productive with these technologies. And so what we decided is that we said, why not build an open source platform that everybody can use so that all the companies that don't have the resources or potentially the skills to go and build their own platform can use this platform and have the same capabilities that these existing companies have. So that's what became Kubeflow. And so briefly, the motivation is that ML applications are distributed systems. So a lot of people tend to think about ML as being about complex algorithms and really difficult math. But if you actually look at ML systems that are in production, you have all of these services and systems that go around and are there to support the machine learning algorithm. So you have services for doing data collection, you have serving infrastructure, resource management, monitoring, etc. And most of your time is actually spent in these surrounding systems that really are more about DevOps and less about machine learning. And so that's really the challenge of getting applications into production. And so one of the ways that we've learned in the industry and at Google to deal with this complexity of distributed systems is that continuous integration and continuous delivery is critical. So really, the motto is, if you push on green, so to speak, you can push early, you can push more often, and what happens is that you actually have fewer problems, and those problems tend to be less severe. I put a couple of quick citations on the docs. You can go and slides. You can go look at them. There's some papers to actually sort of back this up with some research and some papers from Google and other people. And so the key idea is that we have for traditional DevOps and application deployment, we have a really good cycle where we can develop, push, build, test, and deploy our applications. And so we really know how to iterate quickly and push software into production. And that's really been critical to dealing with the complexity of dealing with distributed systems. So we want to do the exact same thing for CI/CD, for ML. But we have a couple complexities that we have to deal with. In terms of machine learning is a little bit different. So one of those differences is that you have different tools when you're developing code. So a lot of data scientists or ML engineers are using notebooks. They're not using sort of traditional IDEs. And so because of that, we have to build some of the integrations and tools to make it easy to go from these notebooks and these development environments into artifacts that can actually be deployed. And then finally, we have to figure out when we have a model deployed, how do we go about actually validating that model and seeing whether it's actually improving the predictions or quality of our model and validating that we're actually solving some important business problem. And so the CUJ that we're going to go through today, so CUJ stands for Critical User Journey, and using the technologies of Kubeflow is we're going to try to close this loop. So we're going to try to develop a model in a notebook. We're going to then use Kale, which is a project Stefano developed, which makes it easy to convert a notebook into a pipeline. We're then going to run this pipeline using Kubeflow Pipelines. And then finally, we're going to take advantage of Rook to validate our model and investigate how well it's doing so that we can figure out how we improve our model to actually get it, make further improvements on the problem we're trying to solve. And with that, I'm going to hand it off to Stefano.
Okay. Thank you, Jeremy. I'm going to just reiterate over what Jeremy said. So since this is a data science-focused tutorial, we're going to use Kubeflow pipelines. And I'm not going into details of exactly what exactly is Kubeflow pipelines, but all you need to know is that it is a general platform for building composable workflows that are based on Docker containers. And it comes both with a UI for tracking jobs, experiments, runs, and the Python SDK for building components and pipelines. Now, first, we are going to see how you are going to learn how you can deploy single Jupyter Notebook as composable pipelines without using this Python SDK, but just a graphical user interface. And then you're going to learn how to have complete reproducible pipelines using data versioning and volume snapshots. And just as Jeremy said, the first point is tackled using Kale. And then Ilias will introduce you to the second part using Arrikto's data management software, Rock. I'm talking about deploying a Jupyter Notebook as a composable pipelines because having pipelines instead of, say, deploying the notebook in a single instance VM has many benefits, like clearly defining the workflow and every step so that every step is clearly isolated and you can like parallelize different steps, run hyperparameter tuning, or develop more collaboratively on different steps at the same time. And also it becomes easier to use data versioning with Rock or with any other software. And having a composable pipeline lets you run single steps on different hardware like CPU VMs or GPU VMs based on the environment requirements. Now, without using Kale and Rock, this is what a typical workflow for developing pipelines on Kubeflow might look like. So first you write your usual machine learning code. Then you would have to build Docker images for either one for every step or multiple Docker images based on the requirements of the components that compose the workflow. After that, you would need to actually define the workflow using the Python SDK, then compile it and upload it to Kubeflow pipelines. Amending the code would mean to go back to the creation of Docker images if you have new libraries, new requirements. So build new Docker images, push them, recreate the workflow, push it to Kubeflow pipelines, run it, etc. With Kale and Rock, it becomes very, very simple because you just have a notebook. You write your code there, you can run it locally, and then with Kale UI that I'm going to show you very soon, you will be able to tag the notebook cells to compose, to create this workflow, and then with the click of a button, just push it to Kubeflow pipelines. Whenever you need to amend the code, just go back to the notebook, change some code, and then deployment is seamless. All right, so we can start with the hands-on part. We have prepared this code lab with all the instructions you will need to follow. So please follow this link to open up the code lab. And I'm going to hand over to Ilias, who will introduce you to the GCP environment we're going to use.
So Okay, I'll leave you a moment to join the link. This is our code lab. Every step we're going to follow today is written in detail in there. If you face any issues, we have several people roaming around the room to help you. Just raise your hand and they'll come to you. We will be deploying a MiniKF on GCP. That is a virtual machine, so at some point we will choose some zones. Please choose one of these shown in the presentation. And just pick one randomly. Don't everyone choose the first one, and everything will be okay. So, has everyone joined? Are you okay? Okay. So, this is the introduction. We've talked about Kubeflow, and let's see the goals. We will install MiniKF. We will convert the Jupyter Notebook to a Kubeflow pipeline without any CLI or getting our hands dirty using SDK. We will click a button and run a Kubeflow pipeline. And we will also version our notebook and our data during the pipeline. You will only need the GCP credentials you should find in front of you in your seats. And I'm going to the next step. OK. We're going to set up our environment. Let's all join GCP console and log in. I'm already logged in, so if you follow the link, you should see a prompt to put in your credentials. And make sure, once you are logged in, you have chosen the only project you should see. It should be the same. If you haven't selected any project, just click here and choose the one from the list. It should look like this.
Make sure you're in an incognito browser. Otherwise, you might have problems trying to log in or mess up with your existing Gmail account.
Yeah, thanks. OK. Let's click on the search bar and type MiniKF. We'll talk about MiniKF later on. Let's start deploying it for now. It will take about 15 minutes. So if you search for MiniKF, click on Launch on Compute Engine. You can choose your deployment name. I'll call it KubeCon demo. And I'll choose one of the zones. Let me remember. Central 1, West 1, or West 2. I'll choose Central 1. And leave the rest with their defaults. You may be prompted to click on a checkbox here to agree with some terms. Now we're waiting for our MiniKF VM instance to be deployed. You can follow the details in the code lab on your own pace. We encourage you to do it all together so we know where everyone is. Go back to the code lab page. Yeah. Have you joined? It will take some time until we are deployed, but then it will be fun. Right. Okay. So my virtual machine instance is up. I will SSH into the machine. And now we'll see some on-screen instructions just to watch the progress of full MiniKF deployment. We will talk details about MiniKF later on. So what I should do is just type the command MiniKF to see the progress of the provisioning script. This MiniKF, the procedure of the deployment is to pull some images, then deploy a Kubernetes cluster using Minikube, a single node Kubernetes cluster. On top of it, a single node Kubeflow distribution will be deployed, and our software ROC for data management and data versioning. Okay, while this is done, I will continue with the slides. We're setting up MiniKF, and let's go. So what is MiniKF? MiniKF is a virtual machine. It consists of Minikube, a Kubeflow distribution, and Arrikto software, ROC. It's very easy to deploy. You can deploy it either on GCP, on your laptop, or any on-prem infrastructures in just 15 minutes. And that's pretty much it about it. So why MiniKF? And why Kubeflow, to be honest? This is a figure taken from Google's TFX paper. It's a high-level overview of a machine learning platform. There are several stages, several components. We start with the storage and data management utilities. Then there are several components performing the actual machine learning. Then there's a shared configuration framework and the job orchestrator to organize these components. And a front end is required to manage and analyze and evaluate the results. So Google has open source TensorFlow components that perform the machine learning, and Kubeflow encapsulates these along with others to perform AI. It also comes with an intuitive UI for management and evaluation. Kubeflow runs on top of Kubernetes, so that's our orchestrator. But what about the storage? That's where we come in the picture. And our software, ROC, a data management platform. What's ROC? Let's say you have multiple distributions across the world. Kubeflow distributions. So you do your experimentation somewhere, you do your training in some other infrastructure, let's say the cloud, and then you serve your results for production in some other cluster. You have data there, you have libraries, you have PVCs. ROC makes sure that your environment code, libraries, data are synchronized across all locations. And let's see an example. So this is your data. Your data you want to run machine learning on. And let's say that while your pipeline starts, you decide to take snapshots. So once validation step ends, you have a snapshot of the validated data. Then the rest of the pipeline continues. Again, we take a snapshot of the pre-processed data. Then the training happens, but we get a failure. That failure could be anything from code problems to whatever. What can you do now? What can you do then? You can clone the input of training, have insight in the data, and debug it. See if the data were good, decide if that was a problem or the code, fix it, and then continue with your process. And the pipeline would succeed at some point. So let's see what's up with MiniKF. Okay. Some internet connection probably. Try that again. Okay. So the provisioning script continues. We don't need internet connection for that. Now Rock is getting provisioned, and then Kubeflow will be. I think this will take about 6 minutes, so let's all sync and see what's going on. If you need any help, just okay. Have we managed to get to the provisioning script process? While this is taking place, you can take a look at the code lab. I will. We have set up our environment. Hopefully, we have started installing MiniKF. Okay, we're about here. No. It's a data versioning platform. We take snapshots, and I guess that's pretty much it.
Need special instances to run on, like NVMe enabled by AWS I?
Yeah, it actually enables you to have super fast ephemeral storage as primary storage. So
No prerequisites on the type of instances of the cloud, like NVMe support?
If you have a question, raise your hand. We'll turn on the microphone around so everyone can hear you.
we do support NVMe. Any local storage should be okay. Was that the question?
Not all the instances of the cloud support NVMe.
Yes. What would it be? I mean, ROC supports NVMe, supports local SSDs. So if your node has some storage, then it should work. Okay, so my MiniKF is up. Yours should be in a little bit. And once it is, you will have your own Kubeflow distribution up, a single node distribution. I will not need this window. All the information exists in the project. And then back to the deployment manager. There's a MiniKF dashboard URL. We will click on it in a second. Should I leave some time for everyone to have his MiniKF up, their MiniKF up? So How many people have deployed MiniKF? Please show hands. Oh, great. That's good. So let's have one more minute, and then we'll proceed. Okay, let's proceed. If anyone is left behind, the CodeLab has all the steps we will follow. So, in this page, we can see a link for the MiniKF dashboard, and we have some credentials, username, the password. Please don't log into mine. So, okay, let's copy the password. And make sure you copy exactly the password, because there are some browser issues that might make you copy some extra spaces around it. Okay, I have it copied. I will go to that URL. We sign it with a self-signed certificate for now. Users with macOS, Catalina, and latest Chrome might not be able to join, but Safari works just fine. Just use some other browser. So we have to proceed. This is the login page. I'm now logging into MiniKF using the credentials shown before. And this is the landing page. So we have logged into MiniKF, logged into Kubeflow, proceeded with the certificate. This is the dashboard. From here you can get to any Kubeflow component, pipelines, notebook servers. There's also a snapshot store. Let's click on it. It will take us to Rock UI. Credentials are needed there. They are the same you used before, so same username, same password. All your snapshots will be stored here in buckets. We will not need this for now, just we will come back later. So back to the CodeLab. We are on step 4. Now we'll create a notebook server. To do that, we will head to our MiniKF and to notebook servers and create a new server. I will give it a name. I'll call it KubeCon Demo. When you create this, make sure you choose the second image from the list, the one with the Kubeflow workshop tag. And I will add data volume. I'll call it data. Please, when you do this, call it data as well, so you can follow the CodeLab exactly as it is. Okay. Make sure, when you create the notebook server, make sure you use this image. This image contains Kale and its UI. We will need this for this tutorial. And add the second data volume, add the data volume, call it data, and click on launch. I'll leave you for a moment to follow the code lab and create one yourselves. If you don't use this image, please go back, destroy the notebook server, and create a new one. Raise hands if you have a notebook server up. Good. Once it is up, just click connect. Okay, let's have a minute to get notebook servers. That's it from me for now. I will come back in a bit.
That some of you are already going through the notebook, some others are a little bit behind. But I'm going to go quickly through the next session of the Code Lab. So if you want, you can follow me here, and then you can replicate it at your own pace. So I will first download the code that we are going to use. So first I move into the data folder where there is the data volume. And then I will clone the examples repository from the Kale organization. You can find the command here on the code lab. We are cloning the KubeCon workshop branch because this example is specific for this workshop. Okay. Oh. Can you see? Do I have to increase the? Yeah, I should, right? Better? I guess so. So now that I have cloned this repository, you will see multiple folders, and each one of these folders contains a specific example with different data and different machine learning challenge that showcases how to use Kale. But today we're going to use the Titanic ML dataset challenge. That is Kaggle challenge that was launched a couple of years ago. And basically here we're building some simple machine learning models to try to predict if a passenger in the Titanic shipwreck survived or not based on the features provided by this challenge. Now, let's verify that this environment has all the libraries we need, and indeed it doesn't. So as you can see, I'm missing the library Seaborn. So in order to execute the notebook, I just want to install the library. And as before, you can copy and paste the command required from the code lab. make sure to use pip3 to install under Python 3 and using the flag -- user. All right. Now you can restart the kernel and relaunch this cell. And indeed, we have all the libraries we need. I won't go through the notebook because it's out of the scope of this tutorial. And instead, I'm going to open up this left panel with the Kubeflow icon and enable it. And you will see some magic happen. So now there is a bunch of information on the left and a bunch of colors on the right. But for now, I'm going to explain you later what is happening. But for now, I'm just going to click the compile and run button. And now some things are happening in the background. There's a taking snapshot dialog that's basically saying that in the background, Kale is interacting with Rock, and it is taking a snapshot of the current workspace that will be used to run every cell in the pipeline that will result from this notebook. And then Kale takes this notebook and converts it to a Kubeflow pipeline workflow. You can see the entire workflow by clicking on the link in uploading pipeline. And this is the structure of the workflow that you can expect this before running the workflow. Every cell in this pipeline corresponds to specific cells in the original notebooks. So Kale did the job of splitting up the notebook, resolving the dependencies, and creating a new pipeline. And we'll see later how all this works. And then you can click on the running pipeline link to see the actual pipeline running. It will take a couple of minutes, and you will see all the steps filling up and completing. Now, while this is going, I'm going to switch back to the slides and talk a little bit more about Kale. And after that, you will have all the time to replicate this and go through the code lab. So, as I said, Kale comes both with the Jupyter Lab extension that provides the UI that you've seen there, and a Python package that acts as a backend to that UI. Kale is able to take as input an annotated notebook and splitting it up and composing a pipeline without the need of using the Kubeflow SDK. Actually, to go back to the lab, I was talking about annotating a notebook. So what the Jupyter Lab extension does is exactly this. It uses all this information on the left, like experiment name, pipeline name here, pipeline description, and annotates the notebook. So that information is saved inside the notebook and becomes portable. Instead, here on the right, all these colors and badges refer to the annotations that we had already made on the notebook itself. So for example, here, the load data badge is referring to the fact that this cell will become a load data step of the pipeline. Here on the right, you can see this edit button, and this dialog is where you can change the annotations of this cell. I will skip cells, for example, will be skipped from the workflow. And I want to show you, here we have, data processing. Here in this case, data processing is a multi-cell component because we have tagged the cell as data processing, and then all the subsequent cells that are untagged will be automatically merged to the first one. There is also a dot that indicates the dependency of data processing to the load data component. And these dependencies can be defined very easily from this box. As you can see here, I have all the other steps defined in these notebooks. OK, so how does Kale do this. So Kale takes as input the annotated notebook. Then internally, it splits up the notebook by creating a graph. And each node in this graph will contain the resulting code of each component of the pipeline. Then some static analysis magic will resolve all the data dependencies between these steps. And Kale will inject some code to serialize and deserialize data when a step is completed and then when an afterwards step needs to take the data that the previous step generated. After all this magic happened, Kale will generate some Python code. Actually, it will generate a single executable script using the Kubeflow SDK to define and upload the pipeline. You can actually see this executable script by navigating here in the tree file. And as you can see, you will find a Python script right under the notebook file. And I won't go through this file, but as you can see, it's very long, very verbose. And basically, this is the script that you would have needed to write in order to deploy that workflow. But Kale did it for you. OK, so this is the high-level view of how Kale works. And I guess I can give you some time to go through this, try to play with it, try to break it, and we'll hear for questions. OK, since it's already the second time in 30 seconds that I got the same question, what is happening here is that a notebook is just a JSON file. So when you are interacting with this extension, what you're actually doing is writing metadata in the JSON file that is the notebook. So if you actually want to see this metadata, you can open up this panel here, the one above the Kubeflow one. And this is the Notebook Tools panel. If you click on Advanced Tools, you will see some notebook metadata. And if you click on Cells, you will see that the cells metadata. And this is where Kale is writing this information. This is why I said that the annotations are part of the notebook, and they are portable. Because whenever you change something from this UI, it is reflected in the metadata saved into the notebook. I want to add another thing that I think it's very interesting. So when I clicked compile and run, you saw the message of snapshot taking, this one. So this is very important because if you remember, we have installed Cburn at first. And when we did that, the notebook ran correctly. If you notice, the pipeline is running as well. So you might wonder on what Docker image that pipeline is running. So the thing is, we're taking the same image that this notebook server is running on. So you have the base environment that is the same. And with a snapshot, we recreate all the new, basically you have all the new installations and specification of the environment ready on the pipeline components. OK, just before coming over, I wanted to add that. I wanted just to show you this slide to tell you that Kale is completely open source. And if you want to contribute open issues, you can head over to this GitHub org. And also, there's a nice Medium blog post that introduces you to Kale and how it works. And you can find it at this link.
I believe most of us have run the pipeline. So this is our run. We can get to it from the link in that panel, the one next to running pipeline. OK. OK. So what we haven't told you since now is that during the pipeline, we automatically take snapshots. That's an option from Kale UI. We've been taking automatic snapshots in the beginning of every step. That way, we know the exact input this step will take. Each state at the very first moment of its execution. Why do we want that? We have tweaked the example we've just run to produce weird results. So I will now show you, I'm going back to the code lab. We've done all these. On step 5, I will now show you how we can reproduce the state of a pipeline steps execution. So let's click on results, this step, and then logs. We have printed the accuracies of each model, and it looks like we've got 100% accuracy with all models. So it looks weird, it's good, but should not be true. So what can we do? We need to see what did the models do. So let's go to random forest and explore it. We are going to explore what happened right in the beginning of random forest. So clicking on random forest and then on artifacts, we see an artifact produced by Kale that has a link to the snapshot taken in the very beginning and all the instructions required to reproduce a state. So I'll do it, you do it right afterwards. I click on the link, Rock UI comes up, and this is the snapshot that was just taken. Let me get you back to pipelines bucket. Oh, back to Rock. So we now have 2 more buckets. A notebooks bucket, that's the bucket where the notebook snapshot taken by Kale, by Rock, called by Kale. So this is our Jupyter lab. And in the pipelines bucket, we store the auto snapshots during the pipeline. This snapshot is a group. It has 2 members. We can see that the one has the keyword data in its description. We can imagine it's the data volume. And the second one is the workspace volume. So we had 2 volumes on our pipeline, and it's these 2. If we click on Show Versions on the top, then we will see all the snapshots taken during the pipeline. Previously, we were just seeing the latest one. Each version has 2 members, the exact 2 members at each point. So let's go back to random forest. Here is where the link you click on will take you. And I'll copy the Rock URL. I'll go back to Kubeflow and create a new notebook server. I will paste the link in the Rock Jupyter Lab URL and click on autofill. All the details are automatically filled. I will just choose a name. I will call it Explore Random Forest. I can see that I have the same image, the same type of volumes. Now we have clones and some environment variables, some extra data I will talk to you about later on. And I click on Launch. During the automatic snapshots, Rock has ingested some data that Kale will grab. Kale will recognize and reproduce our state, take us to that exact point in a notebook, in the specific notebook, where the step would be. And it would have preloaded all the data, all its inputs, and every import we have chosen, every global function we have defined, etc. So my notebook server is up, and I click Connect. Now magic will happen. We'll give it a moment, just a couple of seconds. And now Kale gets all the data ingested by Rock, and we are resumed. I think I will let a couple of minutes for all of us to get here. what we just did is that we are on the 5th step of the code lab, and we got up until this point where we hit connect. How many of you have clicked connect? Okay, let's wait a little bit. Who have reached this point? Okay, I will continue and you can do it later on. So, we have resumed our state right in random forest step. I will enable Kale just to have some visualization of where I'm at. This random forest, and I will run it again and print the accuracy. So I add a print command in the end of this cell. And then I hit Shift Enter. And indeed, I got 100% accuracy. I need to debug it, so let's debug it. I'll go to the previous cell and click on insert a cell below. And I will just print my dataset. That's train df. Okay, so we can see that it contains the survived label. So that's some bug in the input. And it seems like we've trained our models to map one-to-one the survived label with the survived column and ignore every other feature. So we will remove it. I will add the cell, and I will drop that column. To be honest, I will copy the command. Everything is in the CodeLab. So add a bug fix. I will copy these and put them in cell and run again. I've dropped the survived column, and now my dataset looks as it should. I will run again random forest just to be sure, and that's a pretty reasonable accuracy. And since it looks like I've debugged it, I'll run again. I'll hit compile and run again. I'll take a snapshot once more. I will upload the pipeline, and I'll run it. Why do I do that? Because on some other case, my debugging would mean to add extra libraries, add extra data, change various things. So everything should be done from the beginning. And my run has started again, and I'll go watch it. Now you have time to do it. I'll wait for a couple of minutes. Let's see the results for the sake of presentation, since my pipeline got there. And all scores seem reasonable. So I guess that's a success. Okay, I leave a couple of minutes to get on that point, and then Jeremy will do closure.
So how many people got Kubeflow deployed using MiniKF? All right, great. How many people were able to run the notebook through the first time? Okay. How many people were able to run it a second time using Roke and fix the pipeline? Okay, fantastic. So I think we'll just wrap it up here. We're just going to wrap it up by providing a little bit of information about the latest releases of Kubeflow. So we do quarterly releases of Kubeflow. We just released 0.7. There were a couple of new things in Kubeflow 0.7 that we're really excited about. We released KF Serving. So KF Serving is for model deployment and management. It's a simple custom resource, Kubernetes custom resource that makes model deployments easy. It handles complex DevOps tasks like auto-scaling, as well as complex ML ops tasks like inference graphs and building model servers. We've also created a much simpler syntax for deploying Kubeflow, so it's now 1 command as opposed to 3. We've significantly improved the multi-user support to better support enterprises. And finally, we had a bunch of hyperparameter tuning improvements. And then for pipelines, we had a bunch of performance improvements. We've improved the automatic metadata logging. So if you run a TFX pipeline and run that on top of Kubeflow Pipelines, the metadata for all of the steps will automatically belong. And finally, we have new looping constructs with items and with params. So you can easily execute an individual step for a variety of different inputs. So then what's coming next after 0.7? We have a CUJ for notebooks to pipelines. That's what we demoed today. So we're going to be going to Kubeflow 1.0 in January of 2020. And one of the things that's going to be coming after Kubeflow 1.0 is polishing up the CUJ that you saw today so that it's very production ready and you can run that in your enterprise. Kubeflow is a community, so we're open source. So we have over 30 companies participating. You can see all the logos there. We invite you to get involved. You have the links up here and also on our website at www.kubeflow.org. And I think that's it. So thank you very much.